Welcome to this explainer. Look, have you ever asked an AI to, say, book a flight or fix some code, and it just spits back a list of steps that you have to go and do yourself? Yeah, it's super frustrating, right? Well, today we're looking at a massive paradigm shift, a fundamental evolution in how we interact with technology. We are moving away from passive AI chatbots that just talk and stepping into the era of active, autonomous, agentic systems. These are software entities that actually roll up their sleeves and execute complex workflows on our behalf.
To get there, here's our roadmap for today. We're going to cover the Agentic AI leap, break down the anatomy of an agent, explore multi-agent ecosystems, dig into enterprise safety and architecture, and finally, we'll see these agents working in the real world.
Kicking things off with Section 1, the Agentic AI leap, moving from reacting to acting.
Let's really break down the core difference between where we've been and where we're headed. With traditional generative AI, it generates text. It's mostly reactive to your prompt, it has super limited memory, and basically just does one step at a time. It's kind of like a brilliant advisor trapped in a glass box. It can tell you exactly how to build a clock, but it literally cannot hand you the gears. But Agentic AI? It shatters that box. These systems perform actions, they're goal-oriented, they have persistent memory, and they handle multi-step workflows. They don't just give you a recipe, they go to the digital grocery store, buy the ingredients, and bake the whole cake for you. Instead of just answering a question, an agent dynamically orchestrates tools to get the job done. They don't just talk, they act.
To understand how fast this is happening, let's think about the different levels of autonomy. We start at level 0, no autonomy, just your standard software. Levels 1 and 2 bring in human-assisted AI and partial automation, kind of like cruise control in your car. But level 3 is where things get really fascinating. This is conditional autonomy. The AI can handle a complex task from start to finish, but it still pauses to ask for your permission before pulling the trigger. And as we push aggressively toward levels 4 and 5, high autonomy and fully autonomous systems, we're looking at software that operates entirely independently. Hands off. We are watching software evolve from a simple tool you wield into an independent, goal-oriented operator. Which brings us to Section 2, Anatomy of an Agent. Let's look under the hood of an AI coworker.
Fundamentally, an AI agent is way more than just raw code. It's an intelligent software entity capable of understanding goals, making decisions, taking actions, and, here's the absolute kicker, learning from outcomes. It acts autonomously to understand context and execute tasks with minimal human intervention. I really want to emphasize that learning part, because it's a huge deal. If a button on a website moves slightly to the left, a traditional automation script completely breaks. But an AI agent, it realizes the button moved, actively searches the page, finds it, clicks it, and remembers that new location for next time. It literally adapts.
If you think of an agent as a brand new hire, its core components make total sense. The large language model, your GPT-4s or Claudes, that's the brain. It's their reasoning engine. The memory is their persistent notebook. The planning module, that's their step-by-step to-do list, which lets them sequence actions logically. And finally, tool calling. This represents their digital hands. It's the software they use to actually get things done, like logging into your Salesforce account, searching Google, or executing a Python script. They leverage these external systems exactly like you or I would.
Let's zoom in on that memory aspect for a second. Early chatbots basically had amnesia the moment you close the window. Agents, though, have an incredibly robust memory system. They use semantic memory, which is like their encyclopedia of facts. They have episodic memory, a journal of their past mistakes and successes, so they can actually learn over time. Short-term memory keeps track of the current conversation, while working memory acts like a temporary scratch pad for reasoning. And all these long-term memories are stored in persistent databases, often called vector stores. Basically, a vector database is just a highly efficient filing cabinet that lets your AI coworker instantly recall a specific fact from months ago without having to read every single file in the drawer.
All right, moving into Section 3, multi-agent ecosystems, scaling up the AI workforce.
We are moving from a single intelligent agent to multi-agent architectures, where specialized agents collaborate in hierarchical or peer-to-peer teams. Look, a single agent is easier to manage, but it can quickly suffer from context overload. If you ask one human employee to be the lead researcher, head coder, and QA tester all at once, they're gonna burn out and make mistakes, right? Well, AI agents suffer from a digital version of that exact same problem.
Complex enterprise tasks require multi-agent systems where specialized entities work as a highly scalable team. You have one agent entirely focused on planning, another solely on research, another coding, and another validating. They can collaborate as peers or operate in a hierarchy where a manager agent delegates down. It isolates faults and allows for incredible parallel execution. To build these collaborative teams, we rely on powerful orchestration frameworks. We've got LangChain for tool integration, LangGraph for stateful multi-agent orchestration, Crew AI for role-based collaboration, and AutoGen for agent-to-agent conversations. LangChain is fantastic for the foundational stuff, but LangGraph, it handles stateful cyclic execution, which is honestly just a fancy way of saying it lets agents work in continuous loops, double-checking their own work until it's perfect. Crew AI acts like an org chart, delegating tasks among specific roles, while AutoGen lets agents seamlessly chat with each other. These frameworks are basically the management layer for your digital workforce.
Let's jump to Section 4, Enterprise Safety in Architecture. Grounding AI in reality.
Bringing this technology into a real production environment absolutely requires strict safety measures to prevent massive risks. Enter the Agentic RAG workflow. Step 1, the agent determines a knowledge need. Step 2, a retrieval system searches documents. Step 3, the agent reasons over that specific context. And Step 4, the final response is generated and validated. RAG, or Retrieval Augmented Generation, is how we solve the hallucination problem. Without it, base LLMs are kind of like an employee who read a massive library a year ago and is constantly trying to quote it perfectly from memory. Of course they make things up. RAG forces the AI to open the actual company manual, read the exact paragraph, and ground its reasoning in your private enterprise data before it acts.
But even with perfectly grounded data, we use human-in-the-loop safety patterns. These include approval checkpoints, escalation workflows, manual overrides, and human validation. Basically, we intentionally build friction into the system. If an autonomous agent decides, hey, I need to delete this massive database table to fix an error, the system doesn't just let it happen. No way. It throws up a locked door. The agent has to pause, present its plan, and wait for a human engineer who holds the final key to approve it. High-risk decisions always require a human operator to ensure total safety and compliance.
Finally, Section 5, Agents in the Real World. Let's put this autonomy to work. To really grasp the power of this, let's walk through a concrete scenario of a multi-agent system managing an IT incident. Phase 1. Monitoring detects a server issue. The input agent classifies the incident. The log analysis agent examines logs, and the health agent checks system services. Imagine it's 2 a.m. on a Sunday and a critical server suddenly crashes. Before an engineer can even wake up to their pager, the monitoring layer triggers an alert. The input agent instantly classifies the problem. And within a fraction of a second, a swarm of log analysis and health agents dive deep into the infrastructure. They're tearing through thousands of lines of logs at a speed a human simply couldn't ever match, verifying everything without any human prompting whatsoever.
Then we hit Phase 2. The decision agent identifies the probable root cause. The remediation agent restarts the failed service. The validation agent confirms the issue is resolved, and the notification agent alerts the team and stores the learning. The decision agent takes all that context from the swarm, pinpoints the root cause, and tells the remediation agent to autonomously execute the fix. Finally, the notification agent updates the team on Slack and logs the entire learning into the company's episodic memory so it's smarter next time. Think about how paradigm-shifting this is. What used to be a frantic, 4-hour, multi-person crisis in the middle of the night was just handled by digital coworkers in 4 seconds. The human team wakes up, checks their phones, and just sees a notification for an already resolved issue. It's a real game changer.
So, I leave you with this. Is your enterprise ready for the transition from passive chatbots to fully autonomous AI coworkers? As we wrap up this explainer, consider this crucial takeaway. Agentic AI is rapidly becoming the foundation of next-generation software. We are shifting toward human-AI collaborative ecosystems, where your systems don't just chat with you, they act for you. The tech to build autonomous enterprises, self-improving systems, and real-time intelligent automation isn't science fiction. It is here today. The only question left is, how quickly will you empower your systems to start making decisions on their own?